Let's find the critical points of this function, x minus 3 cubed root of x. To find the critical points, we'll need to take the first derivative, and I think it might be a good idea just to rewrite this as 3x to the 1/3 power. That way we see it's a power rule. Okay, let's go ahead and take the derivative, f prime of x. The derivative of x is 1 minus, power rule here, 3 times 1/3 is 1, times x, 1/3 power minus 1 is minus 2/3. What we want to do here is take this derivative and set it equal to 0. The solutions to this equation will be our critical points. If you wanted, you could rewrite this as 1 minus 1 over x to the 2/3, just so we don't have to deal with any negative exponents. And since this equals 0, maybe we can go ahead and just add that x term to the right-hand side. I think we can multiply both sides by x to the 2/3. So we have x to the 2/3 equals 1. We could cube both sides to get rid of that cubed root. 1 cubed is 1. And then to solve for x, let's square root both sides. Make sure here the square root of 1 is plus or minus 1. So these are the x values of our critical points, but the critical points are in fact points. Points are x comma y, so we have a -1 as an x, we have a 1 as an x. We need those y's to correspond, so we'll just plug them into the function. If we go ahead and plug in -1 to our function, that would be -1 minus 3, the cube root of -1. -1 cubed rooted is -1, so this is -1 plus 3, or 2. Our first critical point is -1 comma 2. Let's do the exact same thing, plugging in our other value of 1. Plug in 1 for x to our function. We'd have 1 minus 3 times the cube root of 1. The cube root of 1 is 1, so we have 1 minus 3, or -2. That will give us our other critical point, 1 minus 2.